The reception of code signals over great distances through the medium of radio marked one of the great advances in science. The use of the crystal made this possible. It changed radio frequency impulses into audio frequency current variation. Certain crystals have the property of allowing the passage of a current of electricity in one direction while denying its passage in the other. Half of the wave passes through it. The other half, constituting the rectified radio frequency, cannot pass through the crystal. The cat whisker of the crystal detector gave way to the elements of the vacuum tube, and modern radio was born. The radio tube, like the crystal, is a rectifier and may be used in a radio circuit as a detector. The primary element in all reception is the antenna. The antenna intercepts radio waves so that waves of current and voltage flow down the antenna lead-in. These changes in current vary in intensity with the modulation of the carrier wave. This alternating current flowing in the antenna coil induces an electromagnetic field about it. To this antenna coil is coupled another coil placed in inductive relationship to it. The two coils together, made virtually a unit by the electromagnetic field, constitute a coupled circuit. Some form of such a circuit comprises the first element of a radio receiver. A variable condenser across the secondary of such a unit permits it to be tuned to a particular frequency. The secondary coil, together with its condenser, constitutes a tuned circuit. One side of the tuned circuit may be attached to the plate or cathode of a diode tube. Energy coming from the antenna is transferred by the tuned circuit to this tube. Electrons in the conductors leading to this tube with its cathode and plate move to the plate when it is positive, causing current flow in the plate circuit. However, electrons are repelled by the plate when it becomes strongly negative. Now, if an alternating voltage is applied to the tube, current will flow during one half of the wave only. The diode tube is a detector. A unidirectional pulsating current flows in the plate lead. A headset placed in series with the plate of a diode tube in a radio circuit will enable a signal to be heard. The output of the diode tube is pulsating direct current containing certain radio frequency components. The radio frequency is bypassed by the condenser, while the audio frequency current passes through the headset, resulting in an audible sound. The voltage variations reaching the tube cause current variations in the plate circuit, having the same form and frequency as the grid voltage wave. The audio quality of the diode detector's output, like that of the crystal, is good. We may substitute a triode in place of the two-element tube. We attach the tuned circuit lead to the grid of this tube. We now have the first element of a radio frequency amplifier. The voltage changes coming from the resonating tuned circuit impress themselves upon the control grid of the triode tube, making it alternately more or less negative. Since the grid usually operates in a potential range, all of which is negative, we picture the grid here as varying from strongly negative to less negative. The grid, when it is minus, contains many electrons. When less negative, it contains fewer electrons. Many electrons will pass from cathode to plate when the grid is plus or less negative. Fewer electrons reach the plate when it is more negative. The grid may be made so strongly negative that cathode-to-plate current stops altogether. The grid changes its potential with the changes of the incoming radio frequency wave. The current flow between the plate and cathode follows the changes in grid voltage, describing a wave of the same shape but of greater energy magnitude. The radio frequency signal has been amplified. If the plate current is passed through a coil, current flowing through the coil sets up a magnetic field about it. Another coil may be added, the two constituting a radio frequency transformer. Here we see the first stage of a tuned radio frequency amplifier with grid circuit and tube. The plate coil is the primary of a radio frequency transformer. The secondary of this transformer is tuned by a variable condenser. Radio frequency amplification increases the energy of a wave without changing its form. Steps of voltage and current follow each other. Voltage changes in the grid circuit of the first stage result in larger current waves in the plate circuit of the first two. The same kind of amplification takes place through the coil and tube of the second stage. Several stages of radio frequency amplification may be used. If the plate output of a tube in a radio frequency amplifier is impressed through an RF transformer upon a diode tube, the wave will be rectified. The diode acts as a detector, just as it was seen to do when fed by the energy of the antenna alone. The output of the plate of the diode detector is a rectified current. Only half of each wave is able to pass the tube. The diode tube itself is not an amplifier. It merely changes an alternating wave into a unidirectional pulsating one. The rectified current has been detected and will actuate a telephone headset. We have now followed the radio signal down the antenna through two stages of radio frequency amplification and through a detector tube. The complete set, as we have studied it, is seen to include an antenna coupler, two radio frequency amplifiers, and their associated transformers. This is a basic radio frequency hookup with two RF stages and a detector. The incoming radio frequency waves are amplified and then rectified. The wave, when it reaches the diode detector, is still a radio frequency wave. It differs from the wave coming from the antenna only in that it is of greater energy. It has been amplified. The amplifying tubes in such a tuned radio frequency circuit would be of the Pentode type. The Pentode tube contains heater, plate, cathode and grid, along with screen and suppressor, controlling grid plate capacitance and emission. Here we see a breadboard hookup of a two-stage tuned radio frequency amplifier with a diode tube detector. The two pentodes, the diode detector, the antenna coupler and radio frequency transformers, which are tuned by variable condensers. The superheterodyne circuit is standard in most military receivers. When two wave trains from an antenna or on a conductor are mixed, certain waves tend to cancel each other out. Other waves tend to summate and build up a wave of greater energy. These peak waves constitute what is called the intermediate frequency. This intermediate frequency is of longer wavelength than either of the two waves which mix. It is of lower frequency than either wave, being the difference between the frequency of the two waves. This intermediate frequency is the foundation of the superheterodyne's effectiveness. In this circuit, a triode tube is coupled to an antenna. An oscillator is made to feed the same tube. The wave coming from the antenna is fed to the same tube which receives the oscillator output. The tube receiving the two frequencies is called a mixer. It receives both the radio frequency output of the oscillator and the radio frequency wave from the antenna. The output of the mixer tube is fed to an intermediate frequency transformer. This transformer allows the intermediate frequency to pass. The output includes the intermediate frequency along with other frequencies. The higher frequencies pass around the transformer through a bypass condenser. The intermediate frequency passes through the transformer to the grid circuit of the next tube. The intermediate frequency transformer is closely tuned to the one frequency, allowing nothing else to pass. The signal frequency and the oscillator frequency are such that the plate output will include the desired intermediate frequency at all times. If the signal frequency changes, the oscillator frequency must be changed, so that their difference is always the intermediate frequency. These are gang condensers, suitable for tuning grid and oscillator circuits of such a hookup as we have studied. Often, a stage of tuned radio frequency amplification is placed before the mixer tube. Here, all three circuits are tuned circuits. That of the radio frequency stage, the tuned grid circuit of the mixer, and the oscillator circuit are, as a rule, tuned in unison using a ganged condenser. A very efficient set may contain one or more radio frequency amplifiers, a mixer tube, and an oscillator feeding the amplified wave through one or more IF amplifiers. The intermediate frequency, after being amplified, is detected by a diode detector. The result is great strengthening of the signal before it is changed to audio frequency. The output of the detector, following the intermediate frequency amplifiers, consists of radio frequency elements and an audio frequency current. The radio frequency is bypassed by the plate condenser. The audio frequency current passes through the plate resistance, causing voltage changes to be impressed upon the grid of the first audio amplifier. The output of this first audio stage is an amplified audio frequency current. This current passes through the plate resistor, causing voltage variation to be applied to the grid of the next tube, the second audio stage. The second stage of amplification is usually the final audio stage. Its output is a greatly amplified wave. It has, in a good receiver, the exact pattern of the modulation envelope of the radio frequency wave received by the antenna. The output of the last audio stage passes through a step-down transformer which produces a lower voltage and higher current. This operates a loudspeaker if large volume is desired. The output of this speaker should closely approximate the original signal impressed upon the transmitter microphone. Military communication between ground units, between the ground and aircraft in the air, or between the units of a flight or squadron often depends upon the understanding care given the receiver.